Of course, you can, that doesn't mean that you can't see me. I mean, if you have any problems with academic life or anything related to your academic life, you know where to come. You know my room, right? So you're most welcome to come and see me 24/7. You can also Zoom me 24/7. Okay. The second announcement is about today is the 9th of May. Can I ask you how many of you were born on this day? Can you raise your hands, guys? How many of you were? I'm not going to ask you for money, guys. Come on, don't be shy. No? How many of you guys have the birthday today? No? Anyway, I've been asked to send a special message to one particular person. So you may want to give a big round of applause. This is something I printed myself for one person whose birthday is today, and that person, I hope that person is here today. So can you give a big round of applause to this person, please? Okay. Yeah. After the lecture, you can have this. I printed this myself. You can take this away, whoever you are. You can take this away after the lecture. Hello, guys. And the next announcement, I said that I'm going to give you a special gift today. I meant that I'm going to give you the full solutions for the exam on the 20th of May. How about that? No, I'm just kidding. Right. I mean, you've been really good to me. You've been good students. I will really miss you teaching you guys. I enjoy teaching you guys. So for that, for the memory of teaching you, for being good students, for being listening to me, I brought you some gifts, right? And I brought you some gifts for you. All right, guys. So I brought you some chocolates. So please make sure you take, every one of you, I hope all of you like chocolates. Make sure that you take one, right? At least one. Okay. All right. Now, I'm going to talk about, the first thing I'm going to talk about is quiz 10. Because a lot of people had problems doing quiz 10, right? The question was that you have x1, x2 to xn IID log normal with parameters 0 theta squared. Okay? And this means, this implies that, I don't know whether you understood my solution online, but this implies that log of x1, log of x2, up to log of xn are IID normal with parameters 0 and theta squared. Yes? All right, guys? So, now what many of you did is the following. I'm going to show you what many of you did is that you said that because this is the case, the sum because this is the case, the sum follows this distribution, which is correct, right? And this implies that this follows the standard normal distribution, which is also correct. Then you went on to say that the probability that and this is also correct, right? Now, unfortunately, the next step you made is not correct because, remember, the sum of the log of xi can be positive or it can be negative. So when if it is positive, you can say that okay. Do you follow what I'm saying, guys? Hello, listen, guys. Because the sum of xi can be positive or negative, right? You need to consider the two cases separately. So you need to consider the case where it's positive. In this case, this statement is the same as this statement. That's why a lot of you went wrong, because you did not realize that the sum of xi can be positive or negative. It's not always positive, right? And then you need to consider the case where it is negative. I'm not going to do that. I'm sure I'm sure you know how to do it, right? Is that clear or not? Did you guys look at my email or not? Or do you delete my emails as usual? Come on, guys. Yeah, so this is in the case if it's positive, then you need to do something similar in the case where it's negative. So it's really, I mean, you should take this approach. You should take this approach, then it's really time consuming. It'd be better if you take the approach I described in my solutions. You guys looked at my solutions, Kristen? Yeah, it's better if you take that approach because it's much simpler, right? Okay. All right, now let's get back to exam. There'll be exam, as you know, there will be section A and section B. Section A will contain 4 questions. Section B will contain 3 questions, right? You will need to answer all 4 questions in section A, and you will need to answer any 2 of the 3 questions in section B, right? Now I'm going to give you some hints. I mean, it's kind of a hint that will help you to answer. I'm not going to tell you what the questions are, of course. I mean, after giving you the chocolates, I'm not going to give you more chocolates. Okay? So, all right. Now, there are some hints you need to know. I suppose I mean, I did this kind of questions during my lectures. I mean, at least 1 time. Okay? So here the question is you have a random sample x1 to xn with CDF f, and we want to find the PDF and the CDF of the max of x1 to xn, right? So the solution is as follows. You start, okay, the CDF all right, this is the definition of the CDF of Z, right? Which is the same as saying that the probability that the max of x1 to xn is less than or equal to z. Now, if the max is less than or equal to z, what can you say about each x1 to xn? Right? You follow this? Right? Because if the maximum is, it's like saying you bought 10 different chocolates, right? And the highest price you paid for a given chocolate is, say, £2. So that means each of the 10 chocolates has to be less than or equal to £2. Right? So it's the same argument here, right? Now, because x1 to xn are IID or independent, right, you can say that's because by independence, right? Now we know that x1 to xn each, we are assuming each x1 to xn has CDF f. So this is f. Okay. So the answer is right. So CDF of Z is equal to the nth power of the CD of f. Right. Now, the PDF of Z is just is the derivative of the CDF. So it's the derivative of this, right? And if you differentiate this with respect to Z, you will get n okay. So this is the PDF of little f here denotes the PDF of x1 to xn, right? Is this clear, guys, or no? Yeah, you guys okay with this? Oh, sorry. Yes, no. Please let me know if you should. I mean, I will post this online, so there's no need to copy. All right, the next one. So let me call this 1. Let me call this 2. Right. Suppose. I mean, these are kind of hints that will help you to do some of the questions in the exam. Of course, I can't. I mean, I wish I could tell you what the questions were. All right, so this is the same question as the previous one, but here we want to find the CDF and the PDF of the minimum of x1 to xn, not the maximum. Okay, so right, so we want to find the probability that the minimum of x1 to xn is less than or equal to z, right? Now, I'm going to use a trick here. By the complement rule, I'm sure all of you, do you remember the complement rule? You must have done this in probability 1 last year, right? You can write this as 1 minus the probability okay? Do you follow me? Yeah, this is by the complement rule. Okay, now if the minimum of a sequence of numbers is greater than z, then what can you say about x1 to xn? Let me first write down the answer, then explain. This statement here this statement here is equivalent to the statement that x1 is greater than z, and so on up to xn is greater than z. Do you follow the logic behind it? It's like the same example. For example, if you have 10 different chocolates, the smallest money you give for buying a particular chocolate is, say, £1, right? That means each of the 10 different chocolates must cost more than, or at least £1, right? So that's the same argument here I'm using here, right? Okay, okay. Now, because of independence, are you with me or not? I'm happy to see that there are a lot of you guys decided to come today. Okay, this is by independence, right? Make sure you get at least one chocolate, right? If you came late, please make sure you do get one, right? Okay. By independence, you can write this as this, yeah. And now, once again, I'm going to use the complement rule, right? By the complement rule, this probability can be written as this. Right? That's once again by the complement rule. Right? Now we know that each of the x1 to xn have CDF capital F. So what you have is 1 minus okay, and this becomes 1 minus power n. All right, so this is the answer. This is the answer for the CDF of the minimum of x1 to xn. Do you guys follow me or not? Yes, guys? You okay? Now, to find the PDF, so the PDF of z is simply the derivative of the CDF of z, right? So you need to differentiate with respect to z of yeah, okay. Now if you differentiate this with respect, I'm sure all of you guys are experts in calculus, right? Better than me. So if you differentiate this, you will get the following. Right? So this thing here is the PDF of Z. All right? Is that clear or not, guys? You all right? Okay. So that's number 2. All right, now I'm going to do some examples on, remember, I think I told you like what questions to expect. I mean, unless you deleted my emails, if you look back in the emails, you will see that each A1 is on descriptive statistics, A2 will be on MSc, bias, unbiasedness, and so on, right? So you look back in the email if you haven't already, right? Okay. So what I'm going to do now is do some examples. Okay, so I'm going to start with an example on bias and MSE, right? Because you will get at least one question on bias and MSE, right? Okay, so all right. So this is a typical, this is a typical question that you will get on the 20th of May, right? So you have a random sample from a Bernoulli population with parameter P, and so P is unknown. So there are two estimators for P, P1 hat and P2 hat, and which estimator is better and why? And I did questions like this in the lectures. I hope you remember, or no? Come on, guys. Now, how do you answer this question? Huh? You need to, what do you need to do? The first thing you need to do is to find the bias, right? So we need to first find the bias of the two estimators, right? So let's try to find the bias of P1 hat is the expectation of P1 hat minus P, which is the expectation of 1 over n minus P, and this is 1 over n times the sum of the expectation of xi, right? Now, I don't know whether you guys remember, but the expectation of xi for a Bernoulli distribution is P. All right, and this is of course 0, right? So the bias of the first estimator is 0. Now, one other thing I want to mention is that I think a lot of you asked me this question. The things you need to remember for the exam are on the course website, right? There's a one-page list. I don't know whether is there anyone here who hasn't been to that particular link? There's a one-page of formulas that you need to remember for the exam, right? And that's all you need to remember. Anything else that is not in that page will be given to you as part of the exam paper, right? Okay, can I make that clear, please? So if you haven't been to that one-page link, just come and see me after this class. I will tell you where it is. Yeah? Okay? All right, this is bias of P. This is bias of P1 hat. Now the bias of P2 hat is going to be this. Okay, is this, right? And this is 1 over n plus 1 half okay. So this is 1 over n plus 1 half plus np minus p. Right, and you can simplify this further. NP and NP will cancel. So this will be half minus P divided by n plus 1. Right, and clearly this is not equal to 0. Right, unless something special happens. Right. So in terms of bias, so P1 hat is the better estimator in terms of bias. You see why, right? Because the bias of the first estimator is 0 and the bias of the second estimator is not 0. All right, therefore we would prefer the first estimator, right, to the second, right? Okay, now let's try to find the MSC. To find the MSC, you need the variance, right? Remember this formula. MSC is equal to variance plus the square of the bias. I mean, this is a formula I proved a while ago. But by the way, one more thing I want to mention is that there will be no proofs in the exam. So you should be happy. You should thank me, guys, for not having any proofs. Okay. There will be no proofs in the exam. All right. So we need to use this to find the MSC, right? So we already know the bias, so we just need to work out the variance, right? Now the variance of P1 hat is this, yeah? Now, I don't know whether you remember, the variance for a Bernoulli distribution is P times 1 minus P, right? So this guy is equal to 1 over okay, and this becomes equal to All right, so the variance of the first estimator is P times 1 minus P divided by N, right? Now the variance of the second estimator come on guys, could you please listen to me guys? All right, now remember a constant plus a random variable, the variance of it is, you can ignore the constant, right? So this guy here will become right? You follow me? Because the constant does not affect the variance, right? So this is equal to this, right? Okay, right? So this will be this, yeah? And this will be equal to N P 1 minus P. All right, so this is the variance of the second estimator, and this is the variance of the first estimator, right? So therefore, we can write down the following. Now, the MSC of the first estimator is simply this, right? Okay, and the MSC of the second estimator is all right. Yeah, you with me? Okay, guys. So these, I mean, it's difficult to compare these two, but you can compare the variances. I mean, you can compare the variances. Now, let me ask you whether this is the variance for the first estimator and this is the variance for the second estimator, right? Which one is smaller? Come on, guys. Is this smaller or this smaller? Hmm? No. No answer. Why? Why no answer? Come on, guys. I thought you know algebra. Actually, so now, okay, let's suppose, all right, just for the sake of argument, let's suppose that this is less than this. So this implies right? You can cancel this, you can cancel this, so this becomes n squared is less than 1, which is true. Right? So what I have shown is that the variance of the second estimator is smaller than the variance of the first estimator. So the conclusion is the following. Right? Choose P1 hat if bias is of interest. Remember, the bias for P1 hat, the bias was 0. For P2 hat, the bias was not equal to 0. Right? So you would prefer P1 hat if bias is of interest. Right? And all right, choose P2 hat if variance is of interest. Remember, because the smaller the variance, the better the estimator. So in this case, the second estimator has the smaller variance, right? So if the variance is important, you will choose the second estimator, not the first. Is that clear or not? Some of you look lost, guys. What's up? You didn't have a good sleep? Huh? Are you guys okay with this example or not? Or are you lost? Huh? All right, maybe I've got 5 minutes left, but I will continue this example. All right. Now, if you guys came late, there are 3 boxes of chocolates going around, four boxes of chocolates going around. So if you haven't picked up your chocolates, make sure you do. And also, if you came late, there are 3 example classes today, including the one now. The second example class will take place in G209 from 1 to 2 p.m. And the third example class will take place in G207 from 2 to 3 p.m. And all of you are welcome because these are revision classes. These are revision classes. So I will be doing different questions in each of those classes. So all of you, please do come. Right? But before you go, I want to write down. Don't disappear yet, please. Please don't disappear. And I need to tell you something. Right. All right, guys. Shh. So this is number 4. Could you listen, please? Okay, suppose right? So think about it before you come to the class from 1 to 2 p.m. But before you go, I'd like to say once again, thank you for being my students, and it's been, I really enjoyed teaching you guys. And thank you once again I'd like to dedicate this award. I don't know whether you can see this from where you are. It says most supportive staff member at the university. And I'd like to dedicate this award to all of you. Thank you. Thank you very much. So, thank you. After today, I will really miss you guys. And as I said before, if you have any questions in the second year, you can drop by and see me. You know where I am. So I will see you guys at 1 o'clock in G209. All right? See you. This one, yeah.
Maybe sheet 2, not the quiz.
This one.
Yeah. So what? I understand the step problem, but I don't understand why p of xi, which is equals or less than z, is not 1. Because what I'm thinking is z is the maximum of x1 to xn.
No. This is a fixed value. This is a fixed. I think you asked me that email also.
Yeah.
This is a fixed value.
Yeah.
So it's the probability that x1 is less than equal to z for a fixed z is equal to f of z, not 1.
So that.
Yeah.
So how do we use this stuff? How do we use this z?
This is capital Z, sir. This is capital Z. It's a random variable, right? But this is little z, which is the observed value, right?
Yeah.
So the probability that this is less than equal to z is capital F of z. You have questions, sir? You have the same question?
I see.
No. Could you give me the notes?
Huh?
Could you give me the notes?
Which notes?
These.
He just wants
Yeah,
to
I will post it online. I will scan it and post it online.
Thank you.
Yeah. You have a question?
Thank you.
Because the MSE is the variance plus square, right?
Yeah.
But why we only compare the variance here?
Because it's difficult. Because it's difficult to compare these two. It's mathematically, it would be very difficult.
So
you know.
You can't get the conclusion that the MSE of the P2 is less than the MSE of the P1.
No, you can't conclude that. You cannot conclude that. You
So
can
we
only
have a-
you can only conclude that the variance of this variance is less than or equal to this variance. You can only conclude that. You cannot conclude anything about the MSC.
Siamese, can't you say that they're both consistent estimators?
Yeah, they are both consistent. Yeah, they are both.
So can't you just say that choose P1 in all cases?
Huh?
If they're both consistent, then can't you just say choose P1 in all cases?
No, you can't, because maybe, I mean, you need to really, to answer the question, you need to really compare these two, see which one is smaller, but mathematically it will be difficult.
If they're both consistent estimators, then
No. I mean, what I argued is that the estimator with smaller MSC is the better. It can be both consistent, doesn't matter. The estimator with the smaller MSC is the better.
okay.
So in this case, we just ignore the bias.
Yeah, because it's difficult. It's difficult mathematics. You can try. I mean, I'm sure your math is better than me. You can try your math. Hey, Sue, you want to see me? No, this, Zhu Yang. Yeah, you want to see me? At 1 o'clock. Okay.
Okay, I got it.
You got it?
Yeah, thanks.
Maybe I have a question. So, is solution is for the Christian.
Kristen, yeah, Kristen is here. It's here.
Yeah. So
You have a question?
Which the second tutorial this afternoon?
It's
Where?
from it's G207.
G27.
Yeah, you can come to the first one too. It's from G209. The first one is from G209. The second one
你
G.
去吧，
Yeah.
对，我不去了。我问他，他有。So I did buy that math. So could you tell me? So why I can't do that way? Because I
Why?
Yeah, because then
Why you come to what? Sorry, I didn't understand.
yeah I can
You mean this step here? Which?
yeah.
You mean from this to this?
No, I mean, I know that this one is a wrong answer, but where is the problem?
Where's the problem?
Yeah.
You need to first understand this. Did you understand my method here? Did you understand this? Well, because the sum of xi can be positive or negative,
Yeah.
you need to consider the two cases differently. So here I considered the case where the sum of log of xi is positive. And I haven't finished the answer yet because I had to go to the other examples. So you also need to consider the case where the sum of log of xi is negative.
Oh,
So this is only correct if this is positive.
okay.
But then you need to I haven't finished the solution.
Okay.
You know what I'm this is the
Why can't I just use the
chi-square? Yeah, that's what I used in my solution.
Yeah.
Did you look at my solution?
Yeah.
I just wanted to show to the people, because a lot of people use this way, so I just wanted to show to them why they did it, why they made a mistake, you know. You know what I mean?
So the right answer is using chi-square?
No, there's no right answer. There are different answers. You can do it this way
就
too.
是他说这个是只有你还得考虑它小于0的情况，因为这个它只有它大于0的时候，你才能算出
But
这个
why
情况。
in chi-square you don't need to consider this?
Yeah, because when you square it, it's always non-negative. It cannot be negative. You know, when you have a squared, when you have a squared, it doesn't need to be. It will always be positive or zero.
Yeah.
Positive or zero, so you don't have a problem.
Yeah. Maybe I have another question. So we saw one of the past paper, and there is the R question.
There's no R question this year.
This year, okay.
No R question. Guys, can you take the chocolates with you, because I don't want to take. Hello, can you take it with you? There are some boxes over there. Can you take it with you, please? Also this one, you can have this. This one, there is something here. You can have this one. There are some chocolates here. You can have it. You can take the box with you and give it to your friends.